Let's talk about Amazon Route 53. Now, you can think of it as the literal front door for your entire cloud setup. It's the service that points all your users to the right places, your websites, your apps, everything. And just like the front door to your house, its security is absolutely critical.
So this really brings up a critical question, right? Who is actually holding the keys to your domain's front door? Because if that door is left unlocked, or if those keys fall into the wrong hands, everything you've built behind it is suddenly at risk. So in this explainer, we're going to walk through exactly how to bolt that door shut. We'll kick things off with the shared responsibility model. Then we'll dive into protecting your data. We'll uncover a sneaky threat called dangling DNS, get a handle on access control with IAM, look at logging, and then wrap it all up with the key takeaways you really need to remember. All right, let's get into it.
Okay, first things first. We have to start with what is probably the most foundational concept in all of AWS security.
It's called the shared responsibility model. And honestly, the idea is pretty simple. AWS is responsible for the security of the cloud. We're talking about the physical data centers, the hardware, the core networking, all the stuff the cloud itself runs on. But you, well, you're responsible for security in the cloud. That's your data, your user permissions, and how you configure all the services you use.
Let me put it another way, because this is super important. Imagine AWS provides this incredibly secure apartment building. It's got guards, security cameras, reinforced walls, the whole shebang. That's security of the cloud. But you still have to lock your own apartment door, right? You're the one who decides who gets a key. That's your job, security in the cloud.
Okay, so let's talk about locking that apartment door. This is all about your first line of defense, protecting your data.
All right, these are the absolute non-negotiables. First, use multi-factor authentication, MFA, on every single account, especially your root account. Encrypt all your data in transit with modern TLS. You need to log everything with AWS CloudTrail so you have a clear record of who did what. And please, please do not use your root account for your day-to-day work. You create individual IAM users, and you give them only the permissions they need. This is called the principle of least privilege, and it's beyond important.
Now here's a little gem, a direct warning from AWS that so many people overlook. It seems so harmless, right? You're just putting a customer's email or maybe a secret key into a resource's name tag or a description field. But don't do it. That information can easily end up in places you'd never expect, like billing reports or diagnostic logs, creating a data leak that you'll never see coming.
All right, let's shift gears and talk about a sneakier kind of threat. This is one that can trip up even the pros.
It's called dangling DNS. So what is that? Well, imagine you've got a DNS record in your main domain that's pointing to a set of name servers for a subdomain, but you don't actually control those name servers anymore. Maybe you deleted the hosted zone they belong to. An attacker can spot this, potentially claim those name servers, and boom, they've just hijacked your subdomain and can intercept all its traffic.
And, it's surprisingly easy for this to happen. Let me walk you through it. So you set up a subdomain, child.example.com. You create its hosted zone, you set up the records in the parent domain to point to it, everything's good. Then, down the road, you do some cleanup. You delete the child zone, and you delete the records in the parent zone. Perfect. But then, months go by. Someone on your team is doing some maintenance, sees those old records in a document, and thinks, oh, I should add these back. They add them back to the parent domain, but they forget to recreate the child-hosted zone. Just like that, you've got a dangling record, and those name servers are now a target.
So, how do we stop this from happening? It all comes down to the order of operations. It's a simple rule. Always, always, remove the pointer from the parent domain before you delete the child zone. And when you're creating a new one, you only add that pointer after the new child zone is completely ready and running. If you want an extra layer of security, you can enable DNSSEC, which basically cryptographically signs your DNS responses to prove they're legit.
Okay, this brings us to what I think is the single most powerful security tool you have in your AWS toolkit, IAM, or Identity and Access Management.
First, let's get two terms straight because they get mixed up all the time. Authentication. That's just proving you are who you say you are. It's like showing your ID at the door. Authorization, that's what you're allowed to touch once you're inside. And IAM, that's the whole game of authorization.
And how does IAM do this? With these things called IAM policies. At the end of the day, a policy is just a fancy document that answers one really basic question. Who is allowed to do what, and on which specific resources?
Now, I know what you're thinking. You see this block of JSON and your eyes might start to glaze over. But stick with me. It's actually way simpler than it looks.
This little document is just a statement that says we want to allow the action of creating a hosted zone, and we're allowing it on all resources, which is what that star means.
Let's just pull it apart piece by piece. You've got the effect. That's either allow or deny. Simple. The action is the specific API call, like creating a hosted zone. The resource is the thing you're allowed to do that action on. And the principal, well, that's the who. It's the user or the role that this policy is attached to. See? That's all it is, just simple building blocks.
You know the saying, right? You can't protect what you can't see. And that's exactly where logging and monitoring come into play. So, AWS gives you a whole suite of tools to get that visibility. DNS query logging, that lets you see the actual requests hitting your domain, which is great for security and troubleshooting. CloudTrail, we talked about that one. It's your ultimate audit log. It answers who did what and when for any change made to your Route 53 setup. And then you've got Route 53 health checks and CloudWatch working together to keep an eye on the health and performance of your endpoints.
Phew, okay, that was a lot. So let's boil this all down to the absolute must-know key takeaways.
Number 1, and if you remember nothing else, remember this: the principle of least privilege. It means you never ever grant permissions you don't absolutely have to. Give every single user and every single service the bare minimum set of permissions they need to do their job, and not one bit more.
Number 2, protect your credentials like they are the keys to the entire kingdom, because, well, they are. MFA isn't a suggestion, it's a requirement. And that root account? Lock it away in a virtual vault. You should almost never be using it for anything besides a few, very specific account-level tasks.
And last but not least, you have to remember that security isn't some set-it-and-forget-it task. It's not a project with a start and an end date. It's a living, breathing process. You have to be constantly monitoring, auditing your permissions, and tweaking your policies as your infrastructure changes. So that leaves us with one final thought, a question for you to take away. When it comes to your DNS, is your security posture proactive? Are you getting ahead of threats? Or is it reactive, where you're just waiting for something to go wrong? Something to think about. Thanks for joining me.